Mr. Mhlanga, how can big data be used to ease the implementations of the Sustainable Development Goals?
I think there's a lot of ways it can be used. There's definitely many different ways in which, in many different sectors, of these 17 Sustainable Development Goals that could benefit from initially more digitization, analysis of this data, the application of artificial intelligence of this data, deep learning and other types of techniques on this data. And also, I think the Sustainable Development Goals are really sensors that can be used to continuously collect data and to give us metrics of progress towards these goals. So there's definitely, like clean water is one of them, and you can imagine that having real-time sensors able to detect the status of water, being able to then use historical data to predict changes in the quality of water, these things could be very powerful.
And how can the development of digital technologies actually be made inclusive, and also including developing countries such as Africa, not only in the ethical discussion, but also in the development?
Yeah, so inclusion in these technologies can be difficult because of the economic barriers to some of them. So intrinsically, I think lowering economic barriers to these technologies will make a very big difference, right? Because it'll sort of democratize them, and we've seen that in many areas. Once mobile phone technology became accessible to large numbers of people, that sort of democratized its use. So that's the first thing. The second thing is the actual analytical tools that go with using big data and such big data sets that are collected. Now, that's a little bit more complicated because really the barrier to entry there is to a certain extent economic, but to a great extent it's the level of education of the human capital that a country, a society, a culture, a company has. And bringing that group of people to the level of knowledge that they can actually use tools of analytical tools of artificial intelligence to analyze large data sets is also a structural barrier in itself. So making those two things, I think, will available: cheap technology, cheap hardware, and also, let's call it, skilled practice of the software that you need to analyze the output of the hardware, will make a tremendous difference, and it'll be really democratizing. I think those are two major factors.
And how's the status quo of those two factors you just mentioned at the moment in Africa?
Gosh, Africa is a very, very big continent, lots of countries. I think the status of that is very diverse. I can say that in countries like South Africa, especially in some industries, the approaches are very sophisticated. So there's specific industries where you have very, very high levels of penetration of hardware, and you really have a lot of innovation in terms of software and analytical tools in handling that. So, in a country like South Africa, it's probably looks a lot more in some areas, not in all areas, but in some areas, like some of the more advanced countries in the world. For others, I think universally, Africa is not in such a good state. I think in the healthcare system, the barriers to digitization are very high. I think the barriers to conversion of clinical data or patient data, and even getting biological data and using that in a digital environment is still very inchoate, very much at the beginning, and so that in itself means that even if you do have the most sophisticated artificial intelligence tools, there's not enough big data to play with.
You're also doing research in the field of AI. What is your research about?
Well, our research on the AI side isn't really fundamental research in AI. Really, our research in this area is focused on how we can use precision oncology and artificial intelligence to be able to really change the landscape of cancer in Africa. That's a very ambitious goal. So one of the key things that we've tried to do is to try to develop really cheap ways to be able to take cancer samples and to be able to do genomic analyses of these cancer samples, and then to try to use other types of clinical data and phenotypic data to be able to train our AI models. And we're trying to do that very cheaply using combinations of different markers and using very sort of cheap ways of sequencing, DNA sequencing of tumors that can really allow us to do this at scale. And then with these large data sets, starting to be able to apply artificial intelligence tools to them. So that's really what we focused a lot on in South Africa. And we've also developed some startup companies in this space to try to assist and accelerate that development.
At the moment, most of the human genomes which are digitized are of European or Asian origin. And why is the digitization of the African genome that important at the moment?
I mean, there's several reasons why they're important, because I think human ancestry, we all know we came from Africa. And I think what's even more important about that is the diversity of the human genome in Africa. It remains the most diverse genome in terms of variants of any genome of modern humans. So these pieces of information by themselves are very interesting from a scientific, biological point of view. So the barriers to being able to digitize, to be able to sequence the human genome in Africa really come back to what I spoke about earlier. There are barriers in terms of the economic cost around acquisition of hardware, and that hardware that can sort of sequence human genomes and do that broadly in different contexts, so in healthy individuals and diseased people, and have very good clinical data to accompany that. That effort is costly, and that effort involves certain amounts of basic infrastructure in those economies, plus the sophisticated technical infrastructure to do the next generation sequencing. So those things remain quite a significant barrier, and they are sort of being met now. There's projects from, for example, like H3 Africa from the NIH, which has really tried to be able to provide funding to be able to bridge this gap to a certain extent. But it's really quite small compared to, say, efforts that are going on in Europe. Like if you look at Genomics England, which is probably one of the most advanced programs in the world, you have over 100,000 people with very deep clinical data and a lot of what's called genome-wide association data in their databases. And so this allows them to be very, very, very predictive when new patients enter the healthcare system about diseases, right? So this is like a game of contrasts that are going on here, and so before places like even South Africa reach that level of sophistication and that size of data, there still will need to be quite transformative investments in infrastructure of hardware and to a certain extent in software.